what is a DX command and how I came to kind of discovering it. But anyway, he did this talk and it was absolutely marvellous, and he explained 2 or 3 things that actually has been the basis of everything I've kind of done. So I'll probably draw this out. So let's just go over here. So he was saying like an inverted V, not a very good dipole, where you've got your coax coming up and the braid goes to one side and the centre of the conductor goes to the other side. And that would be a dipole. And he said that what happens is if this is for, let's say, 7 megahertz, it would also be resonant on every other harmonic. So 2 7s are 14, 3 7s are 21. So what he was telling us that it wouldn't resonate at 7 megahertz dipole wouldn't resonate on 14 megahertz, but it would be resonant on 21. And so I just found that interesting. And he also said the other thing that I found interesting was this business of, but he said a loop is the other way around. And in fact, the benefit of a loop, where you normally got a 4-to-1 balun in here, but if you've got it resonant on 7, it would also be resonant on 14 and 21 and 28 and so on and so forth. And on that basis, I did some experiments with a vertical. So this would be a 40 metre vertical, and let's face it, that would be about 10 metres long. And again, our coax is coming along. The centre of the coax is going to the bottom of this vertical, and then to the braid we'd connect some of these, radials. And you tune it by adjusting the length here. And if it was 10 metres long or 30-something feet, then, so that's 10 metres long, on and around 7 megahertz, we would have a tune. But similar to the dipole, the vertical, we'd also get a tune on, theoretically, 21 megahertz. I don't say I invent things, I discovered it, if you know what I mean. It's very difficult to invent anything when it comes to physics, because physics exists, doesn't it? It's a case of just discovering it. So that was interesting. So I've got some pictures now. We went to a little place called Bude, and that's in Cornwall. And I got to say, we took... I've got a big estate car, a shooting brake, or what do they call it in America? Some fancy name. Big car, with a tailgate and everything. I stashed this full of stuff. I had a roof rack with aluminium poles and everything else. The kids and the dog went in the other car because it was a 2-week holiday and I was going to use it as a complete and utter field day, man. So we went to Bude, but as soon as I got there, all the kit I had taken, I realised I couldn't put up. I was going to put up actually a 40-foot, almost a tower, and guy it all off. But the wind was too great. So I thought, well, I did have a couple of telescopic poles, that I'd bought. I thought, or maybe, I know what I'll do. I'll do this. I quite like 40 metres anyway. I'm down by the sea. So what I'll do is I'll just use the vertical and see how I get on. Anyway, I've got a picture of me. That was the view. And as you can see, I've got the Atlantic Ocean outside. So that was pretty fantastic. And this is my actual little shack. I literally took everything on this 2-week holiday. Wendy was kind of going a bit bananas. Funny story, she said, what's that huge box for? And I actually told a lie. I said that because we were by the sea was going to attenuate the signal, so we needed an amplifier to boost it up. Right. Of course, it was completely the other way around. So that was just a vertical. I guided it off, Wendy and Emily are sunbathing there. And I just cruised around on 40 metres, normally at night, because that was my time. I love crossing my thing is, I don't know what it is, I like pile-ups to America on 40. It's good fun, and you can do that down by the sea because there's lots of game, and I was very loud, and I did really well. However, after 2 or 3 days, I put up another antenna because I had a pair of these poles. This is it in the breeze, this pole here, and I had another 10-metre pole over here, and I put 20 on that. So I now had a switch because I took enough gear with me. I had switches, I had spare coax lines, and I could switch between 20 and 40. Remembering what Nigel had said, all going back, to this stuff here and what resonates where and everything else, and we were talking about fan dipoles, because I haven't done this, but, he said you could do 20 and 40 on the same fan dipole. And, of course, remembering that vertical, all a vertical is that's kind of one side of the dipole, and this is the red lines are the imaginary other side of the dipole. So it's kind of, I see, because I'm a bit thick, really. I'm thinking, okay, so it's kind of vertical is kind of a dipole, isn't it? Where the ground is one side of the dipole. Well, in which case we could probably get a fan dipole, but a vertical. And I have the original picture of this idea, and here it is. This is, I think that's 20 on the left-hand side, and then I might have 15 or 10 or something on the right-hand side. And on this little pole, in the end, I got 4. I got 20, 15, 10, and 6, and it all worked. And now, interestingly, I was just been out for coffee with Wendy, and I was telling her about my little presentation to you guys, and I said I found the picture, the actual picture where I split the vertical into 2. I genuinely don't think I've been the first person ever to do this, but I've got a bit of an entrepreneurial mind, and I thought to myself, well, maybe we can get 20 and 40 on the same element. And you know what? I couldn't. On the day, I couldn't get 20 and 40 on the same element. I had about a 3-to-1 SWR on 20 metres, and I think the reason is, if I go to that camera, I think the reason is, and we use, purple, is that I split this and went up halfway for 20 metres, and I just think that it was too close together. Now, there's some of you in the room here who might not know that I might be leapfrogging ahead of the game, but at that time I was just practicing RF. I used to have a saying, having fun with RF. In fact, I gave that slogan to Withall Radio Club. I now just say, enjoy your radio, but has a little slogan thing. So I've got some pictures here. If I remember to press the right button, it's that one there. So this is a completed mini DX Commander. This is called a Rapide, but the concept's the same. We developed this thinking that I had, if you know what I mean, into a commercial product in the end. So we've got little spreader plates to hold all these wires going up a pole, and our biggest pole, well, Hennis has got a 12.4 metre pole, but this is a 7 metre pole, or 6.8 I think. We've got SO239 here, and then that's 2 aluminium plates. The bottom one has all the radials connected. We'll come to radials in a minute. And then the one on the top, we just fire up and put a load of elements up a pole. I might have some more pictures, just to let you see. And it took a lot of development and trial and error and cost cutting to get to the point where everything just worked fine. We do not supply the number beads which kids have for a little bracelet. Somebody pointed me in the direction. I just thought that was quite good fun, So that is the concept of a DX Commander. Now, interestingly, I got to show you this. I didn't have a blooming really clue what to do. I'm using an open, dirty ballon there, which I don't do anymore. All those nuts and bolts on the radial plate, they're actually grounded underneath. Remind me to tell you about blowing up an element. I tried 80 metre coil. I couldn't get the SWR very good there. I gave up on that. That's the blowing up business, which we'll come to in a minute. Now, this is interesting. 2 weeks by the coast. It's mostly stainless hardware, but I had some galvanised washers. Look at that. That's just in 2 weeks, with salt spray. It doesn't take very long, does it? And we can see how it's just what I had knocking around. There is the little copper wire going around all these bolts to give me a radial plate. I had a little metal clamp. You can't see it very well there. Just here. And I ran my element right past this metal clamp. It was literally 1 or 2 millimetres, 1/16 of an inch away from that clamp. and I just hit too much power at the wrong time, whatever else, and it flashed over to the clamp. So even though the clamp wasn't grounded to anything, it acted as a capacitor. It must have been quite a thing because it was absolutely instant and it blew this wire apart. This is worthwhile finding, actually. The next year we went back and I put 3 in a row of these. That's probably, I haven't curated these, so I apologise if it's a bit. Again, this is just for me. I put 3 in a row. So the middle one is the driven one. The one behind is a bit longer, and the one in front is a bit shorter. So it's just the same principles as a Yagi. And then I ran some stupid amount of power. I got this ACOM 2000. The tubes were quite new then. We could easily get over 1500 watts. And I've got literally the Atlantic Ocean right there. There were some Americans actually told me they'd never heard Europe that strong. But I don't know about you, I don't mind people running a lot of power if they've got fantastic ears. So the little guy with 100 watts and the little half-size G5 RV, I could still hear him, you see. So he could get through. I just happened to be very loud, but I had these fantastic ears. We'll muck around with radials for a bit, I think. There's some broadcasts. So Rowley, for instance, Rowley ZL1BQD, you know, he was in the broadcast business for many years, and there's a few of my subscribers in the States. You know, you got to remember, as soon as you start doing presentations and doing a bit of YouTube and stuff, you realise that there's people out there in their niche that really know their marbles. You know, they really know the stuff, because it's anything. Doesn't matter whether you're a surgeon, a brain surgeon, you know, a scientist, or whatever else. Everybody has a niche. Everybody's good at one piece of it. And the thing is, with amateur radio, the topic is genuinely huge. And, you know, so when it comes to radials, right, not everybody knows the answers. So, but the broadcast engineers, there was some, I've done a lot of research, on written research. I don't know when it was. I'll invent. Let's say it was 1932, okay? Somebody did an experiment, I don't know who it was, and they wrote a paper, and basically it said, if you're in the broadcast industry, and you know, in America, and you're putting up this, you know, big tower, you know, on the medium wave band, then what you must do is you'll put your tower up, and you will put a ground mat of... Yeah, 100 minimum of 120 quarter wave radials. What Rowley has actually qualified to say, if that's let's say a 400 foot, whatever that is, 120 meters or something, tower, these are normally the same length as the tower. All right, 120 of them. But that was never challenged, really. So they kept on down there. Now, we're luckily is that Rudy Sevens and November 7, I've never met him, never spoken to him. I don't know anything about him, other than the fact, my goodness, has he done some research. He's, I suppose, a little bit like me. He's just fascinated, like, what would happen if? So, I've got a chart in front of me here, which we'll cover in a minute. But one of Rudy's main experiments, he did these experiments where he measured all sorts of things, you know, with a far field plot and everything else. And then what he did is he cut all these radials in half, but reattached. He got this bit here, and he reattached it there. So he had the same amount of copper in the ground, but then they weren't quarter wave anymore. He cut all these off, you see. They were now eighth of a wave, okay? And he discovered that, I mean, I think that he did notice a very, very small difference, but it would be imperceptible. It would be impossible to tell without a scientific instrument. So for radio amateurs, you know, maybe it was 0.1 of a dB. He never actually quoted the number. I think it was so small, but it was reliably so small. But that's important because we'll come to that in a minute. I will zoom in because we're only interested in the dotted line and the straight line just above it. So what we've got is the signal improvement in dBs for, this would be a quarter wave sitting on the ground, and what he did is he put a ground stake in, and that was his baseline, okay? So There, the baseline is at the bottom left where it says 0. Okay, number of radials 0. And then he put 4 radials on. Each of these segments going along the bottom here is 2 radials. So he's putting 4 radials and then he's measuring 4 radials. And 4 radials from no radials gave him a signal improvement of just over, and it says it there, 1 dB. Okay, so we'll do a bit on dBs in a minute, just to put it into perspective. So that was 1 dB. And then what he did is he went to 8 dBs and measured it again. And that 8 radials, measured it again. He got to 1.6 dB signal improvement. Okay. And then the next time he measured was at 16. So I'm just going to zoom out a bit here. 16, there it is there. And the signal improvement from 0 to 16 was 2, let's call it 2.2. It's not quite, it's 2.18 or something. So 4 radials gave him 1, and 16 radials gave him 2.2. So that was 1.2 dB difference between 4 radials and 16. And if we go to 32, he ended up with 2.4. So the difference of 4 radials and 16 radials was not even 3 dB. In fact, was there ever 3 dB? If you can be bothered to put in 4 radials down here, bottom left, 4 radials, but you went a bit like me and you put in, let's say, 30 quarter waves now, your signal improvement would be 1.4 dB. Okay, the difference between 4 and 32. And if you went 64, oh my goodness, you might get 0.1 to 0.2 of a dB. So let's just break this down and say, okay, well, I mean, let's just do some basic numbers here, because, I mean, I don't know about you, but the best, if 16 is giving me 2.2 bananas and 64 is giving me 2.5 bananas, 2.2, I mean, 0.3 dB between 16 and 64, then, well, I don't know. I mean, I might as well, not even 1 dB, might as well just stick with 16, okay? So let's just work all this out. Let's just take, say, the 20 meter band. Okay, so 20 meters. So a wavelength is 20 meters, right? So a quarter of a wavelength, 5 meters. Quarter of a wavelength. Now, if we do 16 of these, 16 times 5 is basically the same as 4 times 20. So that's going to be 80 meters. Right, now this is when the broadcast engineers go, oh, I don't like when you say that, right? So, but I'm going to anyway. So 80 meters as a fraction of the 20 meter band, right, is 4 wavelengths. 4 wavelengths of copper. Bearing in mind, he did this business where he cut them all and put them in half. So what you could do is 4 wavelengths of wire. So if you think, let's say, the 40 meter band with 4 wavelengths, 4 fours, that's 160 meters, right? 160 meters of wire, and it doesn't really matter how you cook it, whether you want quarter waves, 8 waves, longer one over there, shorter one over there, it just doesn't matter, right? It's that 4 wavelengths, back to this chart here, is giving me, is the same as 16, is giving me this nearly 2.2 bananas on 40 meters. But if I used the same radial system on 80 meters, then I'm going to be using half the radials. So half the radials would be 8. So the difference between 8 and 16 radials is 1.6 there, 2.2 there. So, okay, if we use our perfect 16 quarter waves or 32 eighths of waves, and we use that on the 80 meter band, not 40 meter band, we're going to lose half a dB. Big deal. Because you've got to remember on the dB front is that, 3 dB. Have you ever done the test? You find a nice station, S7 or 8, you go, hey, you're on 100 watts, Turn it down to 50 for me, will you? Now, you will notice a little bit of a difference. Hardly. Was that conditions or, what else? Because half or double is 3 dB. He's turned that down, 100 to 50 watts. He's turned it off by 3 dB, hasn't he? And again, if you double it from 100 to 200 watts, you're adding 3 dB. And now, I normally can just about detect the difference. 3 dB is just about detectable. Just about. Not a lot, but just about. 6 dB I can definitely, that's supposed to be an S point. Yeah, that's kind of worthwhile writing home about. So if you do an interesting antenna, parasitic array or something, and it's giving you somewhere between 3 and 6 dB of extra forward gain, maybe 10, 12, 15 dB of front to back. It's kind of really handy. You're talking to some guy, so you're in South Africa and you're beaming, presumably northwest to New York, northeast to God knows where. I don't know what's behind you, but certainly in Europe, we'll have the Russians and the big Germans and the Italians kind of behind us, and we're trying to get into the US. So a bit of front to back's really happy. A Rowley, for instance, in New Zealand, he wants to dial away the Indonesians and Japans because he's trying to get to the US, or the other way around. So 3 to 6 dB front gain is very handy, but more often than not, it's the back gain that's important. Rowley taught me something, just like Nigel, G4NRR, said that, a dipole is every other harmonic, a loop is every harmonic, a vertical is every other harmonic, and that kind of went, yeah, okay, I'll buy that. I can kind of move forward now because I'm a simpleton. There's some commercial antennas you can buy, isn't there, where you look at it and you go, how the hell does that work, right? What is all this stuff? And people buy them and they plug it in and they go, it's great, don't they? I don't know. Have they ever compared it to anything else? I've got no idea. It's very difficult, isn't it, to say that your current antenna is the best one you've ever had. Let's say you had a linear amplifier that you could just keep winding the power up forever, just conceptually. So in other words, you weren't throttled by your radio. So if somebody says, I can't hear you very well, you just add another 10 dB. Oh, I can hear you now. So that's transmit, isn't it? If you just had a linear amplifier and you can just put more coal on, eventually someone's going to hear you. So that, in a weird way, you can kind of shelve the idea of how efficient you're trying. Don't get me wrong, we still need a good transmit antenna, right? But where and I suffer from this, people tell me on my live streams, there's people in the US calling you, and I can't hear them, right? Well, there's more people calling you than you think. You can't hear them. So it is definitely, in my opinion, we should really be working more on our receive signal. Because if you've got something like, I don't know, even one of my verticals, they adequately transmit everywhere, all right? And normally it just follows the propagation. We know, don't we, that once the sun's gone down over here, we normally transmit a bit more over there. And when the sun's coming up, 40 metres does that, 20 metres in the main. We just know that. So you can follow the grey line, you can follow daytimes and everything else. And I've done WSPR, WSPR, Weak Signal Propagation Reporter, done all that. And you can see at every time of the day that normally you've got this kind of, it's almost like having a rotator on a beam. It follows the sun and all that sort of stuff. And at night time it's better on 40 metres. But I do think we should be spending a little bit more time on our receive. So I've got, as an experiment, I have a field that we hire off the landlord, and they dug a trench and filled it all in, put a 4-inch, 120mm pipe, whatever, between, the field and my office, and so we can do experiments and stuff. And I just happened to spot that it was about 90 metres all the way around. So about a foot off the ground, I put this wire. I actually put it on a 4-to-1 balun. Get a perfect tune on 60-metre band, weirdly enough. Never used it there, but I do. And sometimes that is a lot better than any other antenna I've got. So definitely, I do think that if you had this imaginary amplifier where you can always turn it up more, right? You can't do that with your receive, though. You can't just go, oh, give me more receive over there. So that's when, if you're on a budget, I think we ought to play more with receive antennas. And maybe that's a presentation for another day, because you can do all sorts of stuff with, you can phase loops together with different lengths of coax and directionally steer it, you know. So I know I could get another 3 dB minimum to the US by putting 2 loops in that direction and phasing the back one a little bit with a delay line, and I'd get more gain that way and more front to back. You can't see that properly. Front to back the other way. So receive I just think a whole new ball game. And once you've done your transmit, you ought to start looking at your receive. So this just a small loop, you know, I don't know, whatever you've got in your backyard, back garden, whatever you want to call it. And you've got an old 4-to-1 ballon knocking around. You could always have it just at 6 foot off the ground. Have it as a backup. If you cut it exactly for 40 metres or 80 metres, it'll be a nice little transmit backup for your NVIS. But you'll find with modern radios that it'll receive pretty well. By the way, I have got, I put one of these, they call it a loop on the ground or log. And the guy said it's 15 feet, which is, I don't know, 4 metres or something by 4 metres, this loop thing, right? And a little transformer here and the coax. And I've done that. And personally, I mean, yes, it does cut down on the noise quite substantially, but it's pretty blooming deaf. So you've got to wind everything up. You've got to put your preamp on the radio. And you've got to do a few other things to get enough. And don't get me wrong, modern radios have got enough gain, really. You don't need a preamp at the loop. I just found it a wee bit deaf for me. I like a bit more punch, and the big 90-metre loop gave me that. Right, so how are we doing? So Hennis, I think I pronounce it. This is his, he's just bought this. It was a good excuse to go and play with my drone, okay? So it's 12 feet, takes the idea of DX Command to the next level. And I'm going to talk to you about that little coil. There we are, and then we can wrap up. So this has 7 elements with a coil just over halfway up. So it's a fun antenna, 80 to 10, right? I took a few risks and I got there in the end. Most people, Mike and Tom, actually told me, we didn't think you would get this, you would do this, but I did in the end. This is about a month's worth of work getting all the element lengths right, because it's like a huge fan dipole, and it gets to the point where you put your meter on it, and there's that many dips everywhere and there's that many harmonics, you can't quite work out, is that the 12-metre element or is that the 80-metre element harmonic? So I just used to sit there with sometimes an umbrella over my head and the analyzer disconnecting and connecting elements. And then what you'd get is you'd get one element in the right place, but you'd have a harmonic right on the top of it. And then the idea is, do you use the harmonic or do you try and tune it away so you can then, put a dedicated quarter wave or 3/4 wave in? So I think we'll do, I'll just make a note, we'll do the whole idea of a 3/4 wave, and we'll do this coil, because that's a bit of new science for me. Anyway, you got the idea of that. It's quite big, 12.4 metres. I think it's 12.4 metres because the Americans, that's 40 foot, isn't it? Anyway, I wanted to get 80 metres running on this, and there's a couple of ways you could do it. You could, if you have like a 12.4 or 40 foot-ish tree or whatever else, and you want on 80, you could go all the way up to the top and down about to here, and that would linear load. It's like a loading coil, but it loads it everywhere. It's like a big long coil, effectively. And it would tune, and you would get a harmonic, okay? Because just like our harmonic happened wherever it was, that's right. It's 10 megahertz long, and we got a harmonic on 21. By the way, I haven't discussed how does that work very well or not. And that's what I'm going to cover in a moment. You could load it, but we ended up with a harmonic. In fact, I gave one of these to a friend of mine quite a long time ago, over a year ago, and I said, look, I haven't got the time. Just put an element up and back and tell me where the next harmonic was. And the next harmonic was a whisker above 20 meters. And I know for a fact that a harmonic on a vertical generally gets a better match than a quarter wave. So we've got a bit of a problem, is that you'll never get your quarter wave to it'll just ignore it. It'll go, oh, sorry, mate, I got a much better match up here. So I'm just going to use this 3/4 wave here, this harmonic, the third octave. I asked him to do another experiment, which just to put a coil at about, was 5.5 meters. It was just over a quarter wave. And he did this coil, and he said, it was not far from the 20 meter band. Now, I wanted to go one way or t'other. I wanted to either to be exactly on the 20 meter band and then run some tests so it would do 80 and 20 perfectly, or it was completely removed from the 20 meter band so I could then play with 20 meters, because we know a quarter wave on 20 with a decent ground system and everything else works really well. So I, again, as part of my 6 weeks or so that I spent in this field, I went up and I then put a coil around this thing and then carried on up. And sure enough, I got a tune on the 80 meter band. Let's say 3.75, whatever. And that was fine. And you can make fine adjustments by coming back down, and very fine adjustments just to move this frequency up and down, okay? However, that was originally resin. I got it on, 14, so that was meters, 14.6 megahertz. And then I moved the core a little bit, and let's get rid of that because that's confusing me. And then I ended up, that's it, 12.6 megahertz. By moving this coil up about 1 meter, that's what happened. So I literally eat because I sell this stuff, right? So it's very important to me that I design things that work, that are easy to support. So I'm extremely motivated to get things to work. And I wanted 12.4 meters long. Let's get every band we can on it, So in the end, I got it all working. We had this plate, which we made. It says slightly hexagonal. I'll draw it circular. And we put 80, so that's the pole here. We put 80 coming up, and it just, it's right next to the centre of the pole, and it just very lightly helically winds. Not from an electrical point of view, just for engineering. It just stops the element rattling around, okay? And then we did the usual, like a regular DX Commander Classic. So, we got, I don't know, whatever it is, 40 there. And, we got 20. And then we got 17, 15, 12, 10, something like that. And 80. But I was missing the 30 meter band. Now, I read a book recently. It says you do a lot of your problem solving, good quality problem solving. I had a red pen a minute ago. I don't know what I've done with it. And I woke up one morning and realised that, in fact, if I moved this coil and it went from 14.6 to 12 actually I think it was 12.4 megahertz. If I moved it a bit further, maybe I could get this on 10.1 megahertz. And to cut long story short, I did. So I now got 30 meters and 80 meters on the one element. Now, I think it was Mike and Rowley both said to me, I know what you've done. I know what you've done. You've made a trap. So that distance between that coil and the base, so from there to there, I said it can't be a trap because it was greater than, whatever that sign is, a quarter wave. So, for instance, when that coil was about 6 meters up, it was at about 14.6 megahertz. It can't be a trap because if it was a quarter wave, it would have been down here somewhere. Anyway, To cut a long story short, what we think it is, it's just the next harmonic. The coil is affecting the next harmonic, and by moving that coil up and down, we're affecting the next harmonic. Now, it just so happens that the 30-meter band is kind of working too well. I know it sounds crazy, but when you look at all the whisper plots over 2 weeks, 30 meters is too good. Which makes me think it's not a 5/8, it's not a 3/4 wave. I don't know what it is. But if it's that good, maybe I should redesign this with a new cut chart to say, hey, have a dedicated element for 30 meters, and we use the coil on 20, because actually what we might be getting is like a pair of quarter waves, like a VHF collinear, maybe that way. Who knows? Patterns. I know what we could do. I could run some software, unplanned this, but you should be able to get this, I think, really. I just want to show you something. Let's just, before we go, 5.2 meters. 5.2. Why doesn't my keyboard work now all of a sudden? If the battery's going on it, I mean, that's all we need, isn't it? Battery's going on the keyboard. 22. Okay, it's working. 5.2 meters. Wire, 1 base. Hopefully you can see if I just reduce that very slightly in size. I'll show you what the pattern is for a quarter wave, and I'll show you what the pattern is for a 3/4 wave, because it's quite interesting. So this is roughly for 20 meters. SWR 1.42 to 1, whatever. Far field plot. Now, I'm going to skim over the surface here, but I just want you to remember this number. At 175 degrees, so it's the top, I think if I hit my control, anyway, you can see that little circle, which is 5 degrees off of the horizon. Which is where the real DX is, all right? Because it's, by the way, it's always easy to get a good number up here, all right? Very difficult to get a good number down here. So let's just think minus 5.1. Okay, so what happens if we made this a 3/4 wave? All right, so it wouldn't be 5.2, it would be even longer, wouldn't it? It would be about 15 meters long, give or take. Let's have a look. We'll just decide where this is resonant. 14.8, so that's, I'll just cheat. 14.8, and we had minus 5.2. Okay, fine, far field plot. So, the E hammers and QRZs of this world will tell you that a 3/4 wave is a cloud warmer. And it kind of is, right? Look, we've got this fantastic gain up here at 45 degrees, which in the main for DX, I mean, there might be something there at 500 miles, very occasionally on 20 meters. In fact, there will be, because I speak quite often to Mike 0 Delta Whiskey, a fellow called David in the Orkneys. And reality is that probably is about 30 or 40 degrees off the horizon. But, so I'm coming down here to 5 degrees off the horizon to minus 3.3. So in fact, we are 2 dBs better with our 3/4 wave than we were with a quarter wave. And then we can do some other tricks, which I wasn't going to get into now. And the trick is, and I don't know anybody who's got this answer, to be honest. There was some very sort of professor scientist on my channel once who tried to explain, but when I read it, it was a little bit like reading Greek, so I didn't get it. That camera there. So that is a 3/4 wave, right? But what I'm fascinated in doing is what happens if you come back down a bit, so that now becomes 62.5%, which is a 5/8. So the length of that, instead of being 75%, which is there, yeah, well, it would have been up here, I suppose. We reduce the height, but give it a little bit more down here to get a perfect tune to our 50 ohm coax, and reduce the height down to 62.5%. Because what happens then if we just build a 62.5% antenna, which for the 20 meters, 260/12 is about 13 meters. Okay, so 13 is just roughly, but the tune's going to be wrong, you see. 13 meters high, roughly. Okay, roughly. So we got a bit of a shitty SWR here, but we get this traditional 5/8 pattern, and that's when people go ballistic. Go, oh wow, man, this is really good. But down to 5 degrees again. Okay, it's only 1 dB. Minus 2.4 instead of minus 3.1 instead of minus 5.2 or whatever else. So, which is one of the reasons I often say, actually, do you know what? It doesn't matter what you do. You'll never be far off from 3 dB. Okay? That's why on the transmit front, you know, buy an amplifier. just, 100 watts is plenty if the conditions are there. All right? Sure. If it's absolutely marginal, or you haven't got the time, you're trying to break a pile up. I mean, I don't know about you, but I'll put the kettle on and come back and wait for the pile up to die down. Particularly if he's, the sun's coming round, isn't it? And you can hear there's a mega pile up going on, but you can hardly hear him. Which is not going to hear me, even if I put the power on. I might as well just wait for the propagation to go, now it's my turn. All right? There we are, at 13:59 on the 21st of May. You have been watching Callum from DX Commander. Ladies and gentlemen, the show is now over. But it's time for questions. They reckon it's about 6 dB. And there's a lot of argument about exactly the amount of spacing between each one. In fact, Rowley has now come to the opinion that the best small footprint ideal antenna is the 2-element parasitic. Okay, so that would be to a parasitic array. So that's going to be a single vertical here. He gave me all the numbers actually. Let's take 40 meters, and then another one here. And he gave me the spacing between the two at, I think it was 8.7 meters. This one is, I think, only 3% longer than that one. Or is it 5%? 3%. And that's longer. And then he's getting gain going that way. And he said it's fantastic. More importantly, he can't hear the Indonesians and Japanese as much. In fact, there was this Japanese the other day, just because I had a WhatsApp call with him, and he's very, very persistent. He thought, actually, because this guy's very persistent, he ran out to the garden, he dropped this one, dropped it on the ground, because he's driving this one. So there's no coax on that at all, okay? None at all. It's just built and all shorted out. So the radials literally are part of the vertical, right? It's just shorted. He just lay it on the ground, made it disappear, and then the guy came up. I don't know, at least 2 S points. He said he worked that JA, and then there was another pile up of JAs. And thought, oh, to hell with it. Went back out, put this one back up, and he said, and they almost disappeared again. Good 10 dB. It's like they were all running 100 watts. Now they're running 10 watts. So. Would I run 3? If I was going to run 3, I would probably run 4. And you're going to go, why? I'll show you. If I can find it. I know you can only see me. I'll do it that one there. Reopen. Flamethrower. Yeah, this is the one. So this is... So we've got 2 red dots at the bottom of these ones there. There's one there and there's one there. And what we're doing on these red dots is that we're feeding both of them. So we'll come up to a T-piece and feed both of them. And there's a particular length of coax you use on both of these. That's 75 ohm coax. So's that there. Quarter wave, less velocity factor. And a T-piece there. Anyway, that's basically what it is. And just hold on a minute. Could somebody shut my door, sorry? Yeah. Thank you. Well, what happens then if we phase these together? So we've got a pair of these. So we've got this one and this one at the bottom. God, Jesus. Go away. Why isn't that highlighting? Anyway, it's a pair, right? You can see it. So this is 4, and it's a one direction antenna only, okay? And that is the plot. It's absolutely fantastic. So if we now do my thing where I pull down, if you remember it started at minus 5.2, I think, we'll come to 5 degrees off the horizon, 1.8. So we are, say 2, 5, 6, 7. So it's getting on for a 7 dB gain. So that's really, really, really worthwhile. But more importantly, if we look at the back here, we are right at the very back. We're about the same as a vertical actually, but only at low angles, right? So all that normally the heavy QRM is coming in at, normally anyway, your heavy QRM is coming in more locally. You know, it's like, you know, Joe up the road, you know, 500 miles away. Oh, I've got to get rid of him. But that's, so I called it the flamethrower, or did someone else call it the flamethrower? I can't remember now. Where it's basically it's a single, it's one driven element with one parasitic reflector, 8.7 meters behind, and then another set of this, about 62% away. It's quite a long way. 62% of 40 meters, about 25 meters. Right, it's a long way away. Another pair of these with a phasing line in the middle. Either a quarter wave or 3/4 waves, less the velocity factor, blah, blah, blah. And that'll give you a flamethrower. And then if you want to be really stupid, right, wouldn't it be funny? Edit, make stack. So this I originally built, make the stack, as a single. So there's the single, okay? And you're after the gain. So the gain for just a single parasitic array, with one reflector, it gave me about 5 dB, all right, because I'm at minus about 5 dB. So edit, make a stack horizontal. So we now 2, so the existing one plus the new one, and there it is there. And I'll just make sure we're still getting the same numbers. So that's giving us 4. But what happens if we had the space, right, and the wherewithal to go 4? So that would be 8 poles. Each spacing there is about 25 meters. So it's 75 meter wide array. All right. I'll start this thing rolling. Now we're getting this thing here, which is now giving us 4.7 dB. So with 8 verticals all faced together and everywhere else, we're getting on for 10 dB. So if you're running 1,000 watts on a single vertical and somebody were running 1,000 watts with one of these, it'd be the equivalent of the single guy running nearly 10,000 watts. Can you hear me now? Probably. But again, you'd have to fix this, wouldn't you? You would have to fix this. I mean, it'd be hilarious. I mean, I sometimes do weird things, actually. I mean, while I'm talking to you here, I just sort of get this thing that I wonder what would happen if we put 16 in a row. I mean, it would be absolutely insane. And I think actually they probably would have to insane you. Look at this out the front here. Imagine this on. There we are. So that's 5, 6, 7. Yeah, 12 to 13 dB. Imagine doing that on 80, right? That's doing 80. You could and running 200 watts on 80, and facing it to the USA, whatever else. They wouldn't believe you. They'd say, no, you can't be in Saudi. You've got to be in the Azores or something. You're too loud. Because you wouldn't be far off. Your 100-watt radio would be behaving at about 1,800 watts with 12 dB. 13 dB would be 20 times. Yeah, I mean, it would be insane. And then, if you did this by the sea, you could add another 10 dB on again, right? So it would be like you'd be in the next state, right? You'd definitely be beaming all the way around the road. If somebody wanted to build this, how many is this? I would definitely do a deal. Oh, God, I've lost it. Where's it gone? I've zoomed it in. Yeah, so 16. So you'd need, for 80, you'd need 16 12.4 poles, or 16, 18 metre poles, actually. We could do the nebula. It'd be absolutely, you'd have to be mad, wouldn't you? But it would be one of the greatest, most viral experiments on YouTube, I'm sure. Anyway, that was a good question, but I can't remember what it was now. Oh, yeah, is it worthwhile? I wouldn't actually do 3. I would either do 2 or 4. I'd do the flamethrower thing. I really like that idea. I think you get more bang for the buck, as the Americans would say. I actually genuinely don't think it matters, because with an exceptional ground, I actually genuinely believe a quarter wave is probably the same. There we are. I can prove it on the modelling. I can't prove it in real life. I'm not going to do it now, but I genuinely believe that with a 64 radial system, so you're right within, even 32. A 5/8 would be better with like 4 or 8 radials, but it's a trade-off point, and all of a sudden it's like, who cares? It doesn't actually matter anymore.
Okay, you say it's a poor ground. Do you get a better performance with 5/8 versus quarter wave?
Yes, but I don't. Yes, with a poorer ground, 5/8 would probably be better. But it's like I get a lot of people saying, "I'm thinking of doing this with this and doing this and this. Is it going to work?" Right? And I feel like writing back and going, "Give me the definition of work, okay? Because it'll all work, right? It's just how well." So we're always forever somewhere into, if it's not 3 dB, it's 2 dB or it's 1 dB, and it's the point where, is it better? But you'll never know. It's a bit like the guy who says, "Oh, I can only put radials at 180 degrees, like a half moon." Well, I did that on a holiday once, and I was getting out the other way, the wrong way, effectively. But again, on the modelling, it's everything is always within that 3 dB tolerance for me. So it's just, eliminating that to the point where it's maybe 1 dB. And the thing is, a 5/8 versus a quarter wave with an exceptional ground, there's probably nothing in it. With a really crappy ground, there's probably only 2 dB. Well, we did the modelling, basic modelling. There's only 1 or 2 dB, 1.5 dB. You wouldn't, I defy anybody to say, okay, if you go down from 100 watts to 75 watts, which is, I don't know how many dB, is that about 1.5? You'd never know. There we are. My name's Callum from DX Commander. All the best. Have a lovely day. From me and the boys at the club, all the best.
Thank you.
Thank you.
Thank you.
Thank you.
Adios, boys. I'll hit the end button now, and I'm going to get my afternoon sleep to get rid of some of this vodka.
Thank you.